Hello everyone, welcome back to Z Physics. Today we're going to be solving the multiple choice portion of the 2019 OCR Breadth in Physics. This is the AS paper and I provided a link to the official OCR website in the description of this video. Just a little note that these are just my solutions. They are not official OCR exam board solution, and if you're interested in the official mark scheme, I've also given a link in the description. Let's get started with question 1. So the table below shows 4 physical quantities and their units. Which row is correct? So for the first one we have strain. Now strain is actually a unitless quantity. Remember, strain is defined as the extension divided by the original length. Both of those are measured in meters, so therefore it has no units. That's incorrect. B, the unit for charge is the coulomb, so that is correct. The following are also incorrect. Power, of course, is measured in watts, and the force constant, because K, the force constant, is equal to F divided by X, it will be newtons divided by meters. Question 2, we have 4 students each carry out an experiment to determine the acceleration of free-fall g, which is the least accurate value. Now, what is accuracy? Accuracy is how close your experimental value is to the real value. Now, because the real value is on average around the Earth approximately 9.81 meters per second, well, the one which is least accurate is the one which is furthest away from that value, which means that the correct answer has got to be A. Question 3, a uniform concrete slab is placed on 2 supports. The slab sags due to its own weight. Which point A, B, C or D of the slab is under compression? Now this is really interesting, but the top part on the slab, so let's say that the middle goes through here, will be going through compression. Or we're going through maximum compression. The lower part, the lower half, will be going through maximum tension. So good rule of thumb to remember that the top part, when you have a beam which is going down under its own weight, is under maximum compression, and the lower part is under maximum tension. Therefore the correct answer here is B. Question 4, the variation with time t of the force acting on a ball is shown below. Which statement is not correct? Well, the first one here, the area underneath the graph is equal to the work done by the force F. Well, this is, I'm afraid, incorrect. Remember, impulse is defined as the average force acting multiplied by the time. Force times time. Well, if we have to calculate the area of underneath this graph, what we're doing essentially is multiplying the force by the time, and therefore the area underneath the graph will be the impulse. It will not be the work done. So A is incorrect. Question 5. We have a diagram which shows a rotating steam generator, and we have some steam which is being ejected with a force of 0.12 meters. So this one here is going this way, and the one at the bottom is going the other way. So overall they're going to be creating a torque. They're going to be producing some, or there's going to be some work done, and we can calculate that. This will just be equal to essentially the torque. It will be the force times the distance. Now the total amount of force in this case is going to be given by 0.24, because we have 0.12 spinning it this way, 0.12 spinning it the other way, multiplied by pi d. pi d is of course the circumference, so we're going to get 0.24 multiplied by pi times 8.2 times 10 to the power of minus 2. Pulling that into a calculator, we're going to get approximately 6.2 times 10 to the power of minus 2 joules. Question 6. Which circuit below can be used to monitor the variation of light intensity in a room? So the first one is an LED. Should we just write this down? The first one is an LED, and the LED is just used to essentially bring some light into a room, not to monitor it. B is a variable resistor. So let's just write this down as well. This is a variable resistor, which will have nothing to do with the light intensity in the room. However, C is an LDR, and D, of course, is a thermistor. Now, an LDR will change its resistance according to the light intensity. Therefore, the correct answer is C. Question 7, we have a household planning to change all their 60-watt filament bulbs to 12-watt LED bulbs. Very, very wise decision. And what would their annual savings be? And we're given that they'd be using 10 bulbs for about 2,000 hours in 1 year. And given the cost of 1 kilowatt is approximately 15.4 pence. Well, for the filament light bulb, that's going to be using 600 watts, which is about 0.26 kilowatts. Now there's going to be 2,000 of them, and each of them is going to cost 15.4 pence. So it's going to be a total of 18,480 pence, or about 184 pounds. With the LEDs, we are going to repeat the same calculation. However, rather than 600 watts, we are going to be using 12 times 10, which is of course 120 watts, which is equal to 0.120 kilowatts. So all I have done here is multiply the number of kilowatts by the price, and we are going to get 3696 pence. When we subtract those two numbers, we get approximately 14784 pence. Divide that by 100 to get 147.84 pence. So the correct answer is C. Question 8, we have a force of 12 newtons, move an object at an angle theta to the force. We have the distance traveled, and we're given the work done is 52 joules. What is the angle of theta? Well, we're given the formula in our formula booklet that W is equal to Fx cos theta. Rearranging for cos theta, we get that cos theta is W divided by F times X. Therefore, theta will be equal to the inverse cosine of the work done divided by the force times the distance. Our work done is 52 joules, and we're also given that the force is 12 newtons and the object has traveled 9.6 meters, which gives us 63.1 degrees. Question 9 is really interesting. We have a wire, and we're given that the resistance of a wire of length L is 3 ohms. The wire is extended so that its length becomes 1.5 L. Its volume, though, is going to remain the same. What is the resistance of the extended wire? Well, let me just explain this again before I show you my solution. Because we're talking about a wire, we can assume it quite accurately to be a cylinder. So the volume of a cylinder is given by its height, which is going to be the length, multiplied by the area. So the volume is in general pi r squared multiplied by the length or the height of the cylinder. However, I'm just going to write L times A. Now, if the volume is to remain constant, the length will have to increase by 1.5. Well, if the length increases by 1.5, then the area will have to decrease by 1.5, by a factor of 1.5, in order to keep V constant. That is the only way that can happen. Now, because of that, because resistance is equal to resistivity times the length divided by the area, if the length increases by a factor of 1.5, the resistance will increase by a factor of 1.5. But notice that the area will decrease, but resistance is inversely proportional to the area. So this means if the area decreases by 1.5, then the resistance will once again increase by a factor of 1.5. So R is going to increase by a factor of 1.5 twice. Multiplying 3 ohms by 1.5 squared, we're going to get 6.75 ohms, and the correct answer, which is of course D. Question 10, we have a potential divider circuit like so. We have a 4-volt power supply which is connected to a variable resistor, and then we have a fixed resistor. The minimum resistance of the variable resistor is 0 and its maximum resistance is 3R. The power supply has an EMF of 4 volts and no internal resistance. The resistance of the variable resistor is changed from its minimum to its maximum value. How does the voltmeter reading change? Well, this is really interesting. Remember, so the minimum value is 0. So this means that we can make this component have 0 resistance. What this simply means is that the current just goes straight through. There's no loss of energy as it passes through. So essentially it's just like a normal wire. Well, when that's the case, the potential difference between those 2 points is actually equal to 0. That doesn't necessarily mean that there's no current. I mean, if you take a wire and there's no components, the potential difference between 2 points is going to be 0. So at the minimum setting, the potential difference is going to be 0. So this means that the answer is going to be either A or B. Now at its maximum setting, well, when it's set at its maximum, essentially we're going to have the following circuit. One of those resistors will be equal to 3R, and then the other one is going to be equal to R. V is equal to IR, so the potential difference is directly proportional to R when the current is constant, and essentially the split of the voltage will be as follows. If we have 4 volts here, we're going to have 3 volts across this one, simply by proportionality, and we're going to have 1 volt across this one. So therefore the correct answer is B, 0 to 3 volts. Question 11. The waves from the sources X and Y are coherent, and that means that they have constant phase difference, which means that interference can also form and have wavelength of 10 centimeters. So they're in phase at X and Y, which once again is one of the conditions for interference. Which rho gives the correct condition for constructive interference at point Z? Well, if we look at those, the condition that they should satisfy is that path difference has to be a multiple of the wavelength. Now, the path difference is essentially this length, take away the other length. If the path difference is 10 centimeters, that means that the difference between the two quantities will have to be a multiple of them. For these two, for example, their path difference is 15. Now, that is not a multiple of the wavelength. For B though, it's 95, take away 75, which is 20 centimeters, and that is twice the wavelength. Therefore, the correct answer is B. So question 12, which is all about the refractive index and the critical angle. The table shows the refractive index of 4 transparent materials, A, B, C, and D. Which materials has the smallest critical angle? Well, we're going to use the formula. The sine of the critical angle is 1 over the refractive index given in your formula sheet. Therefore, the critical angle is equal to the inverse sine of 1 over n. Now, Given the following values of n, we're going to get 29.8 degrees, and as n becomes smaller, the critical angle will actually be becoming larger. Therefore, the correct answer is A. So, question 13, we have the frictional force acting on an object falling vertically through water is directly proportional to its speed squared. So, the frictional force is proportional to v squared. We can also write that as kv squared, should we wish for some constant k. Well, what is the correct relationship between p, the rate of work done, against the frictional force and the speed of the object? Now, the power is actually given by the amount of force times the velocity. Power is F times V. If you forget this formula, you can derive that really easily. I can do that over here. Power is energy or work done divided by time, the rate of work done. Work done is force times distance. When we divide that by time, d over t is actually giving us the velocity. So power is equal to force multiplied by velocity. Because of that, well, our force is already proportional to v squared, and then we need to multiply this yet again by v. So the power will be equal to k, for some constant k of proportionality, v squared times v, which is going to equal to k v cubed. Therefore, the correct answer is D, the power is proportional to v cubed. Question 14, we have a particle accelerator which is accelerating some electrons for a potential difference of 120,000 volts. We have the current. What is the total energy transfer to the electrons in a time of 2 hours? We're going to use the good old formula that the electrical energy is given by V times I times T. So our voltage is 120 times 10 to the power of 3. That's where the kilo comes from. Our current I is 8 microamps multiplied by 2 hours, each of them containing 60 minutes, each of them containing 60 seconds. Plugging that into a calculator, we get round about 6,900 joules. Question 15, the electric charge on particles is quantized and is a multiple of the elementary charge. Which charge on a particle is possible? Well, only multiples of the elementary charge 1.6 times 10 to the power of minus 19 exist. So this means that, for instance, 1 times 10 to the power of minus 19, that's smaller than the electron charge, cannot exist. 4 is also not a multiple. However, 8.0 times 1.6 times 10 to the power of minus 19 is a multiple. This is equal to 1.6 times 10 to the power of minus 19 5 times. Therefore, well, essentially this is the charge of 5 electrons. So A, B, and D are not multiples, C is, and that's why this is the correct answer. Question 16, all about vectors. We have two forces acting in the plane of this paper. We're given the magnitude and the direction of the two forces which have been shown. Which of the following diagrams is correct? Well, when we add those two vectors, the horizontal components will essentially cancel out. I mean, for instance, we can arrange the vectors to be tip to tail like that. And if we were to do this over here on the side, we're going to see that the resultant vector is pointing straight down. Another way of thinking about it is that you could represent this vector by a horizontal component and by a vertical component which is going down. Now the component here on the left and the component here on the right are going in opposite directions. So if this vector meets this vector, they're going to cancel out, and the only vector that you're going to have remaining is this vertical one going straight down. Therefore the correct answer is A. Question 17, the power has units of kg, meter squared, s to the power of minus 3, were the base units for intensity. Intensity is defined as the power transmitted for a cross-sectional area, P divided by A. So it's going to be kilograms meters squared s to the power of -3, those are the units for power, divided by meter squared, and we're going to get kg s to the power of -3, which leads us to the correct answer being A. Question 18, we have a ball of diameter 2.5 centimeters is held above the ground, and the bottom of the ball is 10.2 centimeters above the ground. The ball is released from rest. This means that the initial speed is equal to 0, and no air resistance to worry about. What is the time taken for the ball to reach the ground? By far the easiest way to do this is to use s is equal to ut plus half at squared. Because u is equal to 0, then we can cross this bit out of the equation. Rearranging for t, we get that t is equal to the square root of 2s divided by a, which when we plug in all of those numbers, we're going to get approximately 0.144 seconds. Just a little note, they're kind of trying to confuse us a little bit. For instance, this bit of information, the diameter of the ball, is not actually needed in this question. If we think about it, let's say that this over here is the diameter of the ball, 2.5 centimeters. We still really only want the distance between the bottom of the ball and the ground, which is of course 10.2 centimeters. Therefore, I've taken s to be 10.2 centimeters. Okay, so question 19. Which of the following waves can be polarized and has a typical wavelength of about a few centimeters? Well, the answer is microwaves. Microwaves have a wavelength of a few centimeters. They're also polarized, or they can be polarized, and the reason why they can be polarized is because they are transverse waves. So just as a reminder that only transverse waves can be polarized. So, and the typical wavelength for a microwave is a few centimeters. Ultraviolet is much shorter. Sound waves obviously can vary in wavelength, but they cannot be polarized because they're a longitudinal wave. And visible wavelength has a wavelength between sort of about 300 nanometers to about 750 or a little bit higher nanometers. Question 20. Stationary wave sounds are produced in the air inside a tube. The tube is closed at one end. So the correct pattern is going to have the following conditions. The open end is going to have an antinode. The only pipes with an open end and an antinode are A and C. However, if we have a closed boundary, we're bound to have a node at the closed end, and the only pipe which meets those conditions that are very, very general for musical instruments and stationary waves in tubes is, once again, the open end has to have an antinode and the closed end has to have a node. The only one meeting those conditions is C. Okay folks, so hopefully you found this video useful. Thank you very much for watching, and I shall see you in the next video.